Alrighty, what we're going to look at today are the inverses, contrapositive, and biconditionals. These all come straight from our original if-then or conditional statement, kind of like what we looked at with the converses yesterday, just extending a little bit beyond that. So when we look at this, each statement needs to be examined individually for truth value. Just because the conditional is false does not mean that its inverse or contrapositive is also false. So you have to look at each one of them differently and make sure you know before you write something down. The inverse of a statement is formed by negating, think about where that's coming from, negating the hypothesis and conclusion. Negative, negating, meaning what you're going to do if the conditional statement is if an animal is a dog, then it has four legs. Your inverse is going to say if an animal is not a dog, then it does not have four legs. Okay, so if we think about this, is the inverse true or false? Okay, well, I want you guys to think about, is that true or false? If it's false, give me a counterexample for tomorrow that we will go ahead and look at. So make sure you have this done for tomorrow. We will look at a couple more examples. I'll take you guys through one, and then I'm going to let you guys try a couple on your own. Write the inverse of the following statements. If it's raining, then the ground is wet. Okay, so all we're going to do is change both of these to a not. So we're going to negate. So we're going to say if it's not raining, the ground is not wet. Okay, you think about it. If it's not raining, the ground is not wet. Well, can the ground be wet from something else? A student last year told me that, yeah, how about if I spit on it? Now that's not a great example because it's kind of nasty, but just an idea. Or maybe if you were running the hose or doing something like that. So you could come up with a counterexample. You could say a hose. You could say you dumped a bucket. Again, there are so many different answers for this chapter. You just need to come up with some sort of counterexample that makes sense. I want you guys to try 2 and 3. Okay, two angles are congruent, their measure are equal. Come up with your inverse of that. If you need to write it as a conditional, do that part first. Scrolling on down. We also have the contrapositive of a statement. What happens with that is we are actually going to go ahead and we're going to form it by negating and switching. So basically it's a combination of converse and our inverse. So we're going to negate and switch. We're going to do both things. So what this looks like is the conditional statement is if an animal is a dog, then it has four legs. So what we're going to do is we're going to put the not in, and we're going to switch our hypothesis and conclusion. So it says if an animal does not have four legs, then it is not a dog. Okay, so this is a little bit trickier. Again, I want you guys to think about if an animal does not have four legs, does that mean that it's not a dog? Is that true or false? If it's false, I want you guys to come up with a counterexample, another thing for you guys to try for class tomorrow. Look at a couple more examples of writing these down. Write the contrapositive of the following statements. If it's raining, then the ground is wet. Okay, similar example. Again, take this hypothesis, this conclusion, and flip-flop them. So it's going to and negate them. So it's going to say if the ground, we'll say, is not wet, then it is not raining. Okay, well, let's think about that. If the ground is not wet, then it is not raining. Okay, is that true or false? Well, if the ground is not wet, then it obviously must not be raining. If it's raining, then it would be wet. So these are a little bit tricky. You kind of have to break them apart, think kind of forwards, backwards, if they're true, if they're false, and then take a look at it from there. I'm going to do one more of these with you just because they are a little bit trickier. Two angles are congruent when their measures are equal. So our contrapositives would be if two measures are not equal, then their angles are not congruent. Okay, so again, read this carefully, think about it. If two measures are not equal, so if we were to say it's like 80 and 90, if they're not equal, then their angles are not congruent. Okay, again, that's true because if they're not equal measures, then there's no way for them to be congruent. So you need to check, are they true, false? If they're false, you can come up with a counterexample. Try number 3 for tomorrow. Last part of this, biconditional statements and definitions. Basically, in geometry, we get definitions from biconditional statements. Things that we can prove are true, we know are true because we can't come up with a counterexample. Biconditional is a combination of the conditional statement and its converse. So you're going to look at both of those. I'm going to show you guys in a second what that looks like. It can be written as P if and only if Q. You can also write it as P if and only if, like that, just as an abbreviated way, where P is the hypothesis and Q is a conclusion. A biconditional is true only when the conditional statement and its converse are true. So basically it has to work both ways. It has to work forward and backward. Converse is when we flip the conditional, so it has to work both ways. So if we look at this conditional statement, if an animal is a dog, then it has 4 legs. If we flipped this, we would say if it has 4 legs, then it is a dog. Okay? So the way we look at this is an animal is a dog if and only if it has 4 legs. We want to see if this is true or false. Okay? So again, an animal is a dog if and only if it has 4 legs. Well, not necessarily true. For example, my aunt had a 3-legged dog. You may have seen dogs that had to have a leg taken off or something like that. So not necessarily true. You can come up with a counter example there. Okay, they do exist. They're a little rare, but they do exist. Okay, so let's look at a couple more examples. Write the biconditional of the following statements. Remember, a biconditional is true only when the conditional and its converse are true, so both ways. So if it's raining, then the ground is wet. Okay, you have to think about this. We're going to rewrite it just as we did above, and I'll scroll up so we can look at that at the same time. So same idea. We would say, it is raining if and only if, the ground is wet. Okay, so again, it is raining if and only if the ground is wet. Okay, so we have to think about this one. And it's not always easy to do. So a good way to think about this, remember we need the converse to be true as well. So if you write the converse, if you flip these two and say if the ground is wet, then it is raining. Okay, is that true? Well, we set up earlier that there could be either a bucket spill, there could be hose, all those things. So no, this is false. The converse is not true or it's false, so the whole thing becomes false. If we look at another one, two angles are congruent when their measures are equal. Okay, if you wrote it as a conditional, it would say if two angles are congruent, then their measures are equal. Again, to think about, that part's true, we know. Going backwards, we would say, so first let's write it as or let's say two angles are congruent if and only if, I'm going to abbreviate it like that, if and only if their measures are equal. Okay, to check it, okay, we already have our conditional. If two angles are congruent, then their measures are equal. We can flip and again write it as if two angles measures are equal, then they are congruent. Okay. So, in this case, if two angles measures are equal, then they are congruent. That is true. So both forwards and backwards works. The original if-then statement and going backwards, the converse, work. So both work, so therefore it's true. I want you guys to try number 3. Okay, biconditional statements are used to write definitions, as I mentioned before. Therefore, all definitions are biconditional statements. So every definition we come up with this year would work as a conditional and a converse. So we look at one real quick, easy example. Definition: a triangle is a three-sided polygon. You guys know that. Biconditional would be a figure is a triangle if and only if it is a three-sided figure. So we need to look at both conditional, converse. If a figure is a triangle, then it is a three-sided polygon. Then when we go backwards and flip these two pieces, the hypothesis and conclusion, and say if it is a three-sided polygon, then the figure is a triangle, and that is still a true statement. If both of these are true, then it is a biconditional, or we can also make it a definition. Again, how do you determine if a biconditional statement is true or false? Well, we need the conditional and the converse to be true. Both parts have to be true. Again, forwards and backwards. Okay, so let's look at another one. Write the definition as a biconditional statement. Determine whether it's true or false. Okay. The measure of a straight angle is 180 degrees. So we would say the measure we could actually say the angle, we want to say the measure, the angle is a straight angle if and only if it is 180 degrees. Again, to check this, we need to check the conditional and the converse, so check it in both orders. So we would say if the angle is a straight angle, then it is 180 degrees. We know that's true. We would say if it is a 100-degree angle, then it is a straight angle. So both ways, flipping it also, both ways do work. So the conditional works, the converse works. So both of them work. Therefore, it is a true statement. Okay, last thing, we're going to go over a couple of these. You guys are actually going to do one tomorrow in class. You're going to come up with your own and let your partner in your group finish it, but we'll do one of these together and then finish one in class. So, now it's time to put it all together. We're going to write the conditional, converse, the inverse, contrapositive, and the biconditional. So a couple things from yesterday and then all three things we talked about today. If you look at this example, it says members of a country club pay a $10,000 fee. Okay. Anytime you get a statement like this, you're always going to assume the conditional is true. So you can write the conditional if you are a member of the country club, you pay a $10,000 fee. Right? And again, we're going to assume that the conditional is true. Anytime you're given a conditional, you're going to assume it's true and then go from there. the converse. Okay, we switched the hypothesis and conclusion. So we're going to say if you pay a $10,000 fee, you are, I should say then, we need that then in there, then you are a member of the country club. Can't write today. There we go. Okay, so look at this. If you pay a $10,000 fee, then you are a member of the country club. Well, you could be paying a $10,000 fee for some crazy rock climbing club that you do in, the hills or the mountains of Arizona. You could be on some exotic safari. So there's tons of things that you could spend a $10,000 fee on. So there are a lot of different options. So we would say false. The inverse, okay, this is where we negate the original conditional statement. So we're going to say if you are not a member of the country club, then you are not paying the $10,000 fee. Okay, so again, if you are not a member of the country club, then you are not paying a $10,000 fee. Okay, again, you could be paying a $10,000 fee for something other than a country club. So again, we would have to say that that is false. Okay, look at another one. Contrapositive. This is where you flip and negate. So you do both things here. So we have if you are not paying a $10,000 fee, then you are not a member of the club. Okay, so if you're not paying a $10,000 fee, then you are not a member of the club. Okay, to be a member of the club, this particular country club, you have to pay a $10,000 fee. So you can't just not pay a $10,000 fee and be a member of the club. So we would say that this one is actually true. Last one, biconditional. What we would say is you are a member of the club if and only if you pay the $10,000 fee. Again, to look at this, we look at these two statements. Conditional, converse. Both have to be true. Conditional was true, converse was false, therefore the biconditional would be false. I'd like to see you guys try number 2. I know this is not an easy concept. We're going to spend some time going over number 2 tomorrow and then filling out this chart together so that we know the notation of each one, how they're labeled. That's not too big of a deal, but I would like you guys to try number 2, see what you can come up with, and we will work through those couple examples and the ones you guys had earlier on here. Make sure you have those done for tomorrow. Good night.